In this video we have the integral of 3x cubed minus 2 over x squared plus 4, and we want to evaluate this. If you want to try it, go ahead and pause the video, see what you can do. Okay, the integrand is a rational expression, but it's improper. The degree of the numerator is larger, so that always tells you don't start partial fractions there. Go ahead and divide the denominator into the numerator. Simplify it, see what happens here. So I have 3x cubed minus 2, and I'm going to divide this long division. I think we did another one earlier similar to this. Got it in descending powers, the dividend and the divisor. So we have 3x to the third divided by, say, x squared. That'll give me a 3x. And we do the multiplication. Partial quotient times the divisor. This will give me a 3x times x squared is 3x cubed. And 3x times 4 is 12x. Then we subtract here. 3x cubed, subtract 3x cubed, cancels. And then it's 0, subtract 12x is a minus 12x. Then minus 2, subtract 0 is minus 2. So we can rewrite this then as the integral of the quotient, 3x. The remainder is minus 12x minus 2, so I'll just put a plus here. Like that is minus 12x minus 2. And that'll have to be over the divisor, which is x squared plus 4. I'm going to break this down into 3 separate integrals. Come back over here then, say it's going to equal to, this will be the integral. The first one is 3x, just distributing the integral there. This will be dx. That'll be easy to evaluate, it's just a little monomial. Then say plus the integral. And then this one, I'm going to break this up into, say, minus 12x over x squared plus 4, and a minus 2 over x squared plus 4. So this will be minus 12x over x squared plus 4. And integrating. Don't have to do that, but it makes it easier to integrate this. And I have a plus the integral of minus 2 x squared plus 4. Variable of integration is x, so I put a dx in all of these. And then we just integrate here. Integral of 3x, that should be no problem for you. Power rule for integrals here. So add 1 to the 1 exponent is 1, add 1 to that, that'll be a 2 here. Divide the coefficient 3 by 2. So the first result then is 3/2 x squared. And then it's a plus here. Now the next one is involving a U-substitution. Anytime you compute the derivative, in this case of the denominator, you get a 2x. And you have that, ignore the constant, you get 2x, the derivative of x squared plus 4 is 2x, but then I have an x in the numerator. So I'm just do it to the side. I wouldn't actually do this substitution here, but just so you can see. Let u equal to x squared plus 4. Then du is 2x. Derivative of 4 is 0. This will be dx. So I'm going to solve for dx then. Different ways to do it. I just say dx will equal to du over 2x. So if I do that, replacing the dx here, replacing the dx by du over 2x. Okay, so this will be du over 2x. So the 2 will go into the negative 12, negative 6 times. You got an x down here, so it's going to cancel this x. So this will leave me with minus 6 du over u. Because x squared plus 4 is your u. So let me just go here then and say this is going to equal then to 3/2. Just rewriting this again, 3/2 x squared. And then the integral of this, remember you can take out the negative 6. So all you have is the integral. If I put the minus 6 out here, all I have is the integral of 1 over u du. 1 over u du. Well, that's natural log of absolute u. Well, what is u? U is x squared plus 4, the absolute value of that. But because x squared is never negative and we're adding a positive 4 to that, I don't need the absolute values. I can just put parentheses there. So I get that. So far I got 3/2 x squared minus 6 natural log of x squared plus 4. And then on the last one here, I can just factor out the -2 if I want, just so that you can see this. Put the -2 out here and make that a 1 there. Bring it down to the next step, -2. And then I have the integral of 1 over x squared plus 4. You can look at that as u squared plus a squared. That's one of the general formulas. I think I derived that one in the last video. So this is going to be tangent. Let me write it as arctangent. So it's in the formula, it's u squared plus a squared, and the integral of this expression right here, using that formula, is u, which in this case is x, because it's u squared, this is x squared, so this will be x over a. A is 2, because 2 squared is 4, so this would be 2. And then the coefficient here is 1 over a. So I just put a 1/2 right here. Dividing that coefficient by 2. So that's basically your answer. We just simplify it here a little bit and just say this 2 and this 2 are going to cancel out. And that's just a 1. I just leave it understood. That's a minus there. So final answer then, and then you plus your constant of integration. I can put this in parentheses just to make it a little bit more clear. So again, final answer 3x squared, or 3 over 2 x squared minus 6 natural log of x squared plus 4 minus arctan of x over 2 plus a constant. That's your formula. Thanks for watching. We'll see you next time.